Hey there, statistics class. I know you're really missing my face, but there's just so much information in this lecture 3.1 on measures of central tendency that I didn't want to get my mug in the way. So in this lesson, we're going to talk about mode, median, and mean, of course, how to compute them, what they mean, and then explain how they can be affected by extreme data values. We're not going to get into trimming means, but I do want to talk about computing weighted averages because you actually have to do that for this class. So the first thing we're going to talk about is mode. Mode is the most frequent value that occurs in a data set. So, for example, count the letters in each word of the sentence and give the mode. Well, 5 is the number of letters in count. 3 is the number of letters in the word the, etc. So all these numbers here, it's just I needed a data set to work with. The first step is to put these values in order. It just makes it much easier. On a very short data set, you can probably look and just identify which number occurs the most frequently. But again, putting things in order usually is a good point. Then you can clearly see, well, hey, there's 1, 2, 3, 4, 5 number 4s. Since you have 5 number 4s, that is the mode. So why is the mode useful? Well, think about it from anything relating to clothing or retail. You're not so concerned about the average shoe size. You want to know which shoes sell the most, or what sweaters, or what jeans or whatnot. So again, the average isn't as useful as knowing which item has the most business and how you can prepare production for that. The second thing we want to talk about is median. And in median means the middle number. Median is quite valuable because half of the data is above the median, half of the data is below the median. It is truly in the middle. So again, I'm going to use the same numbers. I have my information in order. And let me just introduce a couple of other key things. X, of course, from algebra is a variable. It can take on any number of values. Well, in statistics, it's a sample piece of data in a data set. N is the number of samples in a data set. So in this data set, I've got 13 values, 1, 2, 3, 4, all the way up to 13 values. And that's important to know when we find the mean, or the mean and the median. So the median, we first order the data. Then for odd number of data values, the median is the middle number. For an even number of data values, it's the average of the two middle numbers. Well, how do we find the middle number? On a really big data set, you may have to use the following formula, and that is n plus 1, all of that divided by 2. So in this case, I've got 13 sample points in my data set. 13 plus 1 is 14. 14 divided by 2 is 7, which means the seventh value from either end, upper or lower end, is the median. 1, 2, 3, 4, 5, 6, 7. Or I could do it from the other side. Let me get out my fancy highlighter. You guys love it when I highlight things. Son, what color do you want? Bye. You said green. 1, 2, 3, 4, 5, 6, 7. And there it is. So there's my median, my middle value. Half of the values are below, half of the values are above. Now, median is really important because it shows position. So it is not sensitive to changes in extreme values. If your upper value went from 1 million to 10 million, it's not going to change your median. And that's why anything really involving money, a median is a better measure of the middle, because as income changes, as home prices change, you won't skew that data because of an extreme value. All right, my third example here of this 4-part series is the mean. So we're going to be talking about how to calculate an arithmetic average. And again, I've got my data. I'm going to find the number of samples in the data set. Okay, so my n is 13. Now this letter or symbol is sigma, capital sigma in Greek, and it means the sum of. So when you say the sum of x, what we're really talking about is take all these x values and add them up. So take all these x values right there and add them up. Then this final spot here says take all those values add it up, and divide it by the number of entries. And that's what I'm trying to show you right down there. So when we do that, we did that last time. The sum of x is 53 when you add up these values here. There we go, highlighter. You guys like the yellow. 13 is n, and 53 divided by 13 is 4.08. Now you'll notice something very interesting here. When you have median and mode, they are values within the data set, but a mean, like this, 4.08, is not a value in the data set, but it measures an average or a way to represent the entire data. Think about that with children, if people, or with couples. If people have, on average, 2.3 children, no one has 2.3 children, but that is the average number in a family in the U.S. So, one more important thing to note here, and Coral, what color do you want?
Purple.
Purple, perfect. So here's the big difference here. You're going to see one symbol, x bar, and you're going to see another symbol, mu. The difference here is x bar refers to samples, the sample mean, and mu is the population mean. So if you have perfect information, you have all the data out there and you can calculate the mean, that's mu. And again, mu. All right, x bar, I should probably put that in a different color. You guys probably like the different colors. X bar, there we go. X bar is a sample. So if you only have a portion of the data, that's when you'd want you still calculate the same way. It just has different annotation. It's noted differently. All right, let me know if you have any questions on that. Hope I didn't make it too confusing. Now, we've talked about 3 different kinds of central tendency: mode, median, and mean. And we're going to be using mean a lot more when we calculate standard deviations and do other things. This is the important thing to note. A disadvantage of mean, right? Boy, I can almost do a straight line, is it is affected by large values, right? If you have an extremely high or low value, then it will be influenced by that. So mean is not resistant, meaning it will shift dramatically if you add a bigger value or smaller value. Median, on the other hand, median will not change at all. So median, if you make that point from 1 million to 10 million, the median is not going to change. And that's an important thing to keep in mind in discussing this. And you're going to have to do this in Khan Academy, what's going to change values or not. All right, last thing, and I've got 2 slides and we're done. Try to keep this under 10 minutes. Weighted average. So weighted averages, you see them all the time. They're in my class, for example. So weighted average means certain data values have greater importance than other data values. So for example, if a final exam is 60% of your grade and a midterm is 40% of your grade, how will these weights affect your overall grade in a course? Well, here's how it works. A weighted average is the sum of the individual scores times the weight. All of that divided by the sum of the weights. So we'll do several examples of this, and I'm going to show you one example here. So suppose you scored an 83 on a midterm and a 95 on a final. Well, if the midterm's 40% and the final 60%, what that ends up looking like is 83 times 40%, or 0.4, and 95 times 0.6, or 60%. You'll do that math. Actually, it works out to be 33.2 plus 57. And you're dividing that by the sum of the weights. Well, the weights were 40% and 60%. So those weights add up to 1. So 33.2 plus 57 is 90.2. And yeah, your score is high enough to earn an A. I hope this was helpful. Please let me know if you have any questions. Of course, you can go back if you missed anything. And if you really want to see my picture, my face back in the videos, make a comment in the box.